Okay, in this example, we want to take the derivative of a function. This function is f of x equals 2x minus 1 times 3x plus 2. So one of the things to notice about this function is that it's not really in a form that we can take the derivative of. You might be tempted to take the derivative of this and try to multiply the derivative of that, but you can't do that. Okay? If you think back to the rules that we've talked about in this section, all we really have are the power rule, right, and the constant multiple rule, and the sum rule, and the difference rule. We don't have a rule that says that you can multiply two derivatives together to get the derivative of a product, right? And in fact, in general, that's not true. And so, so what you're going to have to do on this particular problem, right, is to try to get this guy in a form that I can apply the rules that I already have. So, oops, a little bit too far there. Put that back on there. So what you want to do is to FOIL out this this polynomial here. And so when you do that, you're going to have 2x times 3x. That's going to be 6x squared. And then 2x times 2 would give you this 4x here. And then I'm going to have negative 1 times 3x. That's going to give me negative 3x. And then I'll have negative 1 times 2 will give me a negative 2 right here. And so now, after I've multiplied that out, you can see that I've got this function plus this function minus this function minus this one. So this is a lot better form for taking the derivative than this one was. Here I had two things being multiplied together. I don't have any rule that tells me how to take the derivative of something that looks like that. But notice here, right, now I have a bunch of additions and subtractions. And there are two nice rules, right, the sum rule and the difference rule, that say that I can split the derivatives across these nicely. So this is a lot better format than what I had before. Okay. All right, so so now I'm just going to simplify that a little bit. I'm just going to add 4x minus 3x is positive 1x, and now I'm in a perfect form for taking the derivative. So I'm just going to take the derivative of this guy and add the derivative of this guy by the sum rule, and then subtract the derivative of this part by the difference rule. Okay. All right. So taking the derivative, right, of 6x squared, right, I have a constant times a function. So the constant multiple rule says just rewrite the constant and multiply by the derivative of the function part. So the derivative of x squared by the power rule, right, is just 2x. Then add the derivative of x, which we talked about, right? The derivative of x is just 1. And then subtract the derivative of 2. The derivative of 2, because it's a constant by itself, right, the derivative of that is 0. Okay? And so then just simplify, and we get that derivative is equal to 12x plus 1. And that's it. So again, if you have a product like this, you're going to want to rewrite it and multiply it out so that you get a bunch of terms in here, a bunch of addition and subtraction that you can split the derivative across by the sum and difference rule.